Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm your teacher Simin Amir, and I'm here again with a new lecture. I hope everything is going well with you and your family. So please keep social distancing and stay at home. Let's proceed to the lecture. This is my lecture number 8 for grade 7, and this is geography. This is chapter number 2, and this is Earth Alive. We are done with this chapter. We have done a folding process in this chapter, volcanism, and earthquake. So I want to show you a glance of the last or the previous lecture in a video.
Calling all parents, you can now watch Kids Learning Tube ad-free by subscribing to kidslearningtubeshop.com. Sign up, sign in for ad-free viewing. What makes the earth shake? It's called an earthquake. Let's learn about the seismic waves that make the ground break. What makes the earth shake? It's called an earthquake. The violent shaking along faults and tectonic plates. Millions of earthquakes happen on Earth each year. That's what the NEIC reports, but have no fear. About 500,000 are detectable, but most are so small they can only be estimated because they can't be felt at all. Out of 500,000, only 100,000 are felt, it's true. And only 100 out of that can cause damage that we can view. What is an earthquake and where can they be found? Most are found between tectonic plates between the ground. 7 major tectonic plates cover our Earth, you see. These are the names of those plates and where they can be seen. This is the South American and Indo-Australian, the Antarctic plate, and the African is great. The Eurasian, Pacific plate, and North American. We'll talk about minor plates in another lesson plan. There are 3 types of plate boundaries running between these tectonic plates. You will see divergent, convergent, and transform. They all cause earthquakes. Let's see how they perform. Divergent boundaries move away from each other, producing rift valleys. Most active between oceanic plates, yes, plates out in the sea. Convergent boundaries move towards one another and collide. That's where you'll find most earthquakes and volcanoes do reside. Transform boundaries are 2 plates that slide past one another. The San Andreas fault line's the best example of this to discover. Between these plate boundaries, the earth moves inches each year, but sometimes the plates get stuck. That's where an earthquake does appear. When pressure builds up from being stuck in this delay, the rock breaks, releasing energy, causing seismic waves. These seismic waves, they shake the ground. That is an earthquake. Let's see where massive quakes are found. The most violent quakes happen in subduction zones, no other. That's where one tectonic plate is shoved beneath another. One plate is forced down into the Earth's mantle, shown here. The other plate's forced upwards, that's where the violent quake appears. This is the same type of earthquake that rocked Nepal in 2015. The Gorka earthquake shook them all. When a quake in a subduction zone happens on the ocean floor, it can create a tsunami or tidal wave. Let's learn some more. A tsunami, also called a seismic sea wave, is a large volume of water displaced in an ocean or large lake. The largest tsunami that was ever recorded was 1,720 feet tall in Alaska. That's enormous. What makes the earth shake? It's called an earthquake. Let's learn about the seismic waves that make the ground break. What makes the earth shake? It's called an earthquake. The violent shaking along faults and tectonic plates. Kids learn it too.
So as we are done with the chapter, here I'm going to give you an assignment. We will do the rest of the question answers of this chapter, and we'll also do some of the objectives in the form of MCQs and diagrams, the diagram of the volcano and the diagram of a seismograph. So the first question for today is, what is an earthquake? The first question is, what is an earthquake? And the answer is, earthquakes are the rumblings, shaking, or rolling of the earth's surface. It is usually what happens when two blocks of the earth suddenly slip past one another or break apart from each other as a result of tension caused by prolonged energy buildup. This is the answer, and even you can make this, you can draw this diagram. Before earthquake, the tectonic plates and fault line, and after earthquake, when the both the tectonic plates slides over each other. So the second question is, what are the types of earthquakes? What are the types of earthquakes? And the answer is, earthquakes can come in three main forms. Earthquakes can come in three main forms, depending on the plate movements that occur beneath the Earth's surface. Depending on the plate movements that occur beneath the Earth's surface. They could occur on a convergent boundary, divergent boundary, or a transform fault. They could occur on a convergent boundary, divergent boundary, or a transform fault. So I'm not going to give you any definition of convergent boundary or divergent boundary or the transform fault, but this is very important to draw the diagrams of these three types to that you will be able to understand it betterly. So please draw the diagrams of convergent when they collide, when two plates collide towards each other. This is convergent. Divergent when they move apart from each other and a rift or a gap is created from which the lava is coming out. That is divergent. And transform when they are just slipping with each other. So that is, they are going in opposite directions. Both the plates are going opposite directions. So there's no need to write the definitions of three forms, but please draw the diagrams of three forms that you will be able to understand it betterly. So third question is, how do earthquakes occur? How do earthquakes occur? And the answer is, earthquakes develop in the crust of the earth. The inner part of the earth contains massive energy. Some of this energy escapes through cracks and other volcanic activity, but the bulk of it is stored within the earth's inner part. Earthquakes develop in the crust of the earth. The inner part of the earth contains massive energy. Some of this energy escapes through cracks and other volcanic activity, but the bulk of it is stored within the earth's inner part. After a period of time, the built-up energy and movement causes huge tension in the plates. After a period of time, the built-up energy and movement causes huge tension in the plates, and there is massive pressure on the fault lines. This intense pressure resulting from energy buildup causes the fault lines to give way and plate moves over, against, or apart from each other. The plates move over, against, or apart from each other. This is the answer of question number 3. Let's move on to the last question. This is the last question of chapter number 2, and the question is, what are the factors that determine the intensity of an earthquake? What are the factors that determine the intensity of an earthquake? The answer is, the factors that determines the intensity of an earthquake are as follow. Number 1, the magnitude. An earthquake with a higher magnitude will cause more damage than one with a lower magnitude. The first one is magnitude. An earthquake with a higher magnitude will cause more damage than one with a lower magnitude. So magnitude is the first factor to determine the intensity of an earthquake. Then the second one is seismic shaking. Second one is seismic shaking. The extent of damage caused by seismic shaking depends on the duration and frequency of its shaking. The extent of damage caused by seismic shaking depends on the duration and frequency of its shaking. That was the second one. So it means that it depends on the duration. The duration is like the higher, how long the ground was shaking. That was the duration of seismic shaking. The duration of seismic shaking means how long the ground was shaking, and the frequency means like the higher the frequency of this seismic shaking, obviously the greater the earthquake's intensity will be, and obviously there will be more damage. Then the third one is distance from the epicenter. Number 3 is distance from the epicenter. You know what is epicenter? Okay, I'm telling you what is epicenter, but this is not the part of the answer. The place on the Earth's surface directly above the focus is known as epicenter. I've given you the definition of focus and epicenter in the previous lecture, and that was like the place on the surface, on the Earth's surface directly above the focus is known as epicenter. So here the point is distance from the epicenter. Damage to places near the epicenter are more extensive than damage to places further away from the epicenter. So this is another factor to determine the intensity of the earthquake, like how far the area is from the epicenter. So this is distance from the epicenter. Damage to places near the epicenter are more extensive than damage to places further away from the epicenter. The fourth factor to determine the intensity of the earthquake is the building material. The building material that are used in building many different buildings. So the fourth one is building materials. And the explanation is the foundations of buildings can be built with shock absorbing materials like rubber that are flexible enough to withstand and absorb the shock waves that result from an earthquake. So some of the material are able to withstand with the um, seismic shaking or the shock waves. Here I am going to give you again this explanation. The building materials, the foundation of buildings can be built with shock absorbing materials like rubber that are flexible enough to withstand and absorb the shock waves that result from an earthquake. The last factor through which we can see what is the intensity of an earthquake, obviously the hazards. the hazards that are caused by an earthquake. So we can say what was the intensity of the earthquake, how hazardous it was. So the fifth one is hazards. And the explanation is densely populated settlement located near the seas and mountains experience a great extent of damage by earthquakes as tsunamis and landslides are more likely to occur in these areas. Hazards. Densely populated settlements located near the seas and mountains experience a great extent of damage by earthquake as tsunamis and landslides are more likely to occur in these areas. So obviously the location is important as areas located near the mountains will be affected from the landslide because landslides are caused by the earthquakes and areas located near the sea or on the coastal area, if the population is on the coastal area, so that might be affected by the tsunamis as tsunamis came with earthquakes. So densely populated means a highly populated area. If the areas near the sea or the mountains are highly populated, so there might be great extent of damage by earthquakes as tsunamis and landslides are more likely to occur in these areas. So here are some objectives of chapter number 2, and these objectives are in the form of MCQs. MCQ means multiple choice questions. So you have multiple choice in your answer here, A, B, C, and D. The question is the Himalayas are considered to be A, very young, B, very old, C, middle aged, and D, the oldest. So I think I should give you the answers as well. And the answer here is A. The Himalayas are considered to be very young. So another MCQ is the amount of force exerted on a rock layer influences the way they dash. A. Vibrate, B. Collide, C. Bend, and D is actually subduct. Here is a little mistake, but that is a subduct. So what is the answer? The amount of forces exerted on rock layers influences the way they bend. So the answer is C, they bend. Another one is further uneven compression of plates would cause one limb to be pushed over the other to create a or an underfold, a fold, overfold, or prefold. We have four options. So here the answer is overfold. This is option C, overfold. Then the next one is the Himalayas were formed approximately A. 50 years ago, B. 5,000 years ago, C. 50 million years ago, and D. 50 billion years ago. The Himalayas were formed approximately, and the answer is C again, 50 million years ago. So the next MCQ is a fold mountain is a type of landform that is created when two crustal plates converge, collide, diverge, or decollide. Again, a fold mountain is a type of landform that is created when two crustal plates converge, collide, diverge, or decollide, and the answer is B when two crustal plates collide. The next one is a seismograph is dependent on the extent of damage caused by a or an earthquake, an air barrier, a volcano, or an explosion. A seismograph is dependent on the extent of damage caused by an earthquake, an air barrier, a volcano, or an explosion? And the answer here is option A, an earthquake. The next one is at the intensity level of 1. Here we are talking about the earthquake intensity. So at the intensity level of 1, people don't feel earthquake, poor buildings may collapse, buildings and bridges collapse, people feel the tremor and windows rattle. At the intensity, or we can say the earthquake intensity level of 1, people don't feel earthquake, poor buildings collapse, buildings and bridges collapse, people feel the tremor and windows rattle. The answer here is option A, people don't feel any earthquake at all because level 1 is very low intensity earthquake. This MCQ is again about the intensity of the earthquake. So objects fall from shelves, plaster walls get cracked, and people feel the tremor at a level of 3, or a level of 4, or a level of 5, or a level of 6. So the answer here is level 6. When the objects fall from shelves and even plaster walls get cracked and people feel the tremor at a level of, that is number 6. It's the option D and level 6. So this one is very easy, I think, and I think you are able to solve it. The magnitude of the earthquakes can be measured by using quick meter, quick graph, seismograph, and tympanic graph. Again, the magnitude of the earthquake can be measured using quick meter, quick graph, seismograph, and tympanic graph. And the answer here is option C, seismograph. This one is easy again. Earthquakes and volcanic eruptions mainly take place at the plate surface, at the plate boundaries, at the terrestrial areas, or at the ocean beds. Earthquakes and volcanic eruptions mainly take place at the option B, plate boundaries. So the answer is plate boundaries. The next one is as the crustal plate moves, it carries along the volcano, which becomes cold, hot, extinct, and old. As the crustal plate moves, it carries along the volcano, which becomes A, cold, B, hot, C, extinct, D, old. Here they're talking about the hotspot volcanoes. So that is hotspot volcanism. When the plate moves, it carries along the volcano, which becomes, the answer is option C, extinct. This one is about hotspot volcanism again. Over time, the underwater volcano increases in height to come out of the ocean surface to form a ridge, a cliff, an island, an iceberg. Over time, the underwater volcano increases in height to come out of the ocean surface to form, the answer is an island. Option C, island. The next one is the volcano that forms from the column of magma is called an underwater volcano, a convergent volcano, a divergent volcano, or a hotspot volcano. Again, the volcano that forms from the column of magma is called, and the answer is a hotspot volcano, which is option D. This is the last MCQ here, which is about the part of the volcano. And this is the passageway which joins the vent to the crater of the volcano is known as A, vent, B, cone, C, pipe, and D, crater. Again, the passageway which joins the vent to the crater of the volcano is known as, so obviously the answer will not be vent or a crater because this is a part which joins vent with the crater. So that is option C, which is pipe. So these were all the MCQs. Please do write these MCQs in your notebook, or even if you want to take the printout, you can paste all the printouts in your notebook. Here is a structure of volcano. So you have to take out the print of this volcano, this picture, and paste it in your notebook. And here this is the labeled diagram here. So you may get this diagram in exams unlabeled, and you have to label it then. And it shows the ash cloud, the ash area, the lava flow, and the layers of ash and lava, the magma chamber, the main wind, the secondary wind, the cone, the secondary cone, and the crater. This is another diagram which is called the seismograph, and you have to label the parts of seismograph in this diagram. So you can see here this area is, this is spring, this is a weight, or we can say a pendulum. Here it is a pen here, and this is a rotating drum. And here this is a base. So you can watch the previous lecture for this diagram. I have given a label diagram there, and even the diagram is given in your book. So please label this diagram, take a print out and paste it in your notebook. Thank you so much guys for watching this video. Please do your work in your notebook, neat and tidy, and make a margin line. You must write today's date and day and maintain your index. We'll meet up again in a new video with a new lecture and with a new chapter. Till then, bye.